trigonometric substitution, and now I'm going to tell you, I don't give a about this. I'm now going to tell you how you should solve integration using complex number. The idea is this. Let me first talk about the standard way. Imagine you want to integrate something like this, okay? That means suppose you need to integrate, okay, the first guy, okay? This a squared minus x squared dx. We make use of what? Sine square theta plus cosine square theta equal 1. This is a, right? Then I just put a, then this is a, okay? Then what? A minus something square. So it's same as what? A minus a cosine theta square, something like that, okay? You see, this is what? A minus this is like a sine square. So you reduce this to a sine square, something like that, and you have a square, and the square and square will cancel out each other. So good. Here is, I let x to be a sine theta. So I have something related theta and x, right? Then what I'm going to do, I'm going to do this, okay? D something. Of course, this is not theta. This is an expression of theta. Then you differentiate the a sine theta. A goes out, so you have a here. Then you have d sine theta, d theta. D sine theta, d theta is cosine theta. So you have this thing equal this thing, and then I put this guy here, then you have this way. Once you have dx equal to a cosine d theta, then this is what? A cosine d theta. And then what is this x? X is this. You throw this guy inside. So this is what I just said, right? Then this becomes a square minus a sine theta. This is a square, right? So square the whole thing. So you have a square minus a square sine theta. And because of this, so this whole thing is a square 1 minus sine square theta. So this becomes a square cosine theta. And that's square. And but the square and the square would cancel each other. Nice. So I have this whole thing become a cosine theta. So you have a square cosine square d theta. So this is the idea. And then if you see a plus, you do tangent. Because of 1 plus tangent square is secant square. And if you see this, you do secant. And then of course, if you can make use of those double angle formula, half angle formula, sum to product to sum, which nobody remember, you make it simple. So this is the oh my gosh thing. Nobody will do this. And then ignore this. This is too much for you. Another example. You have this. And if you know remember the product to sum, you can do this. Now I'm going to tell you, I don't remember this kind of formula because there are so many of them. Then how? The idea is use complex number. It's coming soon. It's coming soon. Okay. So this one cosecant, which is 1 over sine. What I'm doing here is I do a trick. I multiply something and I divide by something. By what? Sine itself. Then I have this. Then I have this. I have something like this, so I can write it like this. And then I do something called partial fraction. I want to integrate this. It will be the same as I integrate what? A plus b. The idea is you split this thing into two parts. This is called partial fraction. So it is u minus 1, u plus 1 equal something you don't know, you just write a here. Okay, u minus 1 plus something you don't know, you just write b here. Okay, so you split it. The general idea is you have f, g, you split it as f something, g something. And your goal is to find the something. So how do you find it? Very simple. This is true for all x inside real number, excluding the thing that make them infinity. So 1 and negative 1. So you put any number here, then it will give you a number here. It will give you a number here. It will give you a number here. And then you compare coefficient. What I want to do first, so I have this right. First, I don't want to see thing in the denominator. What I'm going to do is I multiply the whole expression by the denominator. Then I get 1 equal to u minus 1 times this. Then I have a u plus 1. B, this is plus. So if I multiply the whole thing here, I get the minus 1. So this is what? I multiply the whole stuff by the denominator. Then in this case, now this thing is true for all r, any r. Then I will just put the number x such that one bracket disappear. So if I put x is 1, u is 1, I put u is 1, then I have 1 equal to b 0 because u is 1, and then u is 1, right? So 2a. So a is what? This, I don't care. A is half. So a is half. Then what about if I put u is negative 1, I have 1 equal to a 0 plus b negative 2, right? So b is, this is 0, I don't care. So b is half, negative half. So now I have this thing. So therefore, I have this. Okay, here I make mistake. I forgot half, but now I get back half. Anyway, so this one I have some careless mistake. But this is the idea. So if you want to integrate something like this, you split them, then you can do log. And that's the idea. Another example. So I do this, and then I know the half angle formula. Due to some reason, I have this. And then I multiply this term, not trivial. And then these two cancel out. I have sine divided by cosine, so I have tangent. And then on top is secant. And then this thing, this guy here is d tangent, because d tangent, d is secant square. Which again, if you don't remember this, then you have no way to do this. And then I do this. And then this one can be simplified to this one. Then what if I don't know this? Now here's a big deal. Okay, so this is the important thing. Let me first tell you the higher levels understanding of what I'm going to do. we are doing integration on x on a real number. That means we are working something here. You can imagine we have a ball here moving around here all the time. Now imagine, okay, you are an angel, okay, you stand here, you look at the stuff from the sky. Because you are a two-dimensional creature, this is one-dimensional, so you view the whole thing as what? As a two-dimensional plane. Now you introduce an additional one-dimensional freedom. And now this whole plane now suddenly become complex number. What's complex number? It's a plus bi. And then what? You do the stuff in this complex number world, suppose. So before you do this one-dimensional creature only live here, so it's only doing this. Now you are doing something like this, okay? So this line and this line, if you view from this angle, are the same, because if you view from this angle, you cannot see the height, but you only see the same thing moving here. So you now deal with a two-dimensional thing, but after you finish the working, you project back. So suppose this is a solution in the end, you project back to the R, then you go to here. So these two processes, either you spend a lot of time to study how to do integration of this using crazy formula. What I need to do is, I just need to know one complex number formula, and then I turn this into a polynomial, then I solve it using classical method, which is much more easy to do. Then in the end, I go back to real number, and that's it. And this idea, so I lift from R, so it says lift or extend, and then do what? And then I go back, so I call it go back, okay? Actually, it's called projection. I guess R. So the idea is what? This figure is called commutator diagram. But anyway, this means if I have an integration using those sine cosine, what I want is a solution here. This arrow is very, very complicated, which is not good. So what I'm going to do is, I do this way. This way, now I have two arrows. These two arrows are very easy to do. Then of course I should do this. So what's the arrow here? The arrow here is Euler formula. So imagine you have a complex plane. This is real or real part, okay? This is imaginary part, okay? That means if I have 3 plus 4i, the x coordinate is 3, the y coordinate is 4, okay? And this is not 4, it's 4i, okay? Then actually I have a point here. So complex number is a two-dimensional number. But what about sine cosine? Sine cosine, you know, is this, right? If it is a degree, that means a circle. 350, 60 degrees. So now what I'm going to do is that I have this thing, ei theta is cosine theta plus I sine theta. Then you may wonder, what the heck is this? This is actually triangle. You remember, I have a theta here. If I know this line is my ei theta, then this line is the cosine part. This line is the sine part. But I have a complex number here, so I put an I here. If I have a 7 here, then I have a 7 here, 7 here. So you can think of this as what? This is what? 3 plus 4i. Pythagoras theorem, this length is 5, right? So it's 5 ei, this angle, right? So this angle, I don't know the value, I call it 5, okay? This. So they are the same thing. That means what? I ignore the 5, I can always write this x coordinate and y coordinate as a sine cosine of this angle. So therefore, I have this expression. And with this expression, because of this, then how do I get the cosine? Suppose I give you an ei theta, how do I get cosine? I take the real part of this. So how do I take the real part? So if ei theta give me cosine theta plus I sine theta, let's consider e negative theta. So that means what? That means I have I, but now the theta is negative. So actually I have this. And then multiplying a negative sign with a complex number, you can take out the sign, right? Then it's the same as all the theta here. Put a negative sign. Cosine negative theta plus I sine negative theta, right? And then negative angle for cosine have nothing. So cosine theta. But negative angle for sine become negative. So negative sine theta. So now I have this thing and this thing. What I want to do, you see one is plus, one is minus. Then very naturally you will add these two equations. You add these two, this one add this one, so you have ei theta plus e negative I theta. Cosine plus cosine is 2 cosine. This plus and this minus cancel out, so nothing. And I put the 2 here. So cosine theta is ei theta plus e negative version divided by 2. So now I have a sine. Okay, what about the sine? I just directly jump to the conclusion. It will be ei theta minus e negative I theta divided by 2. You need to divide the 2i, and the difference is here. Cosine is plus, sine is minus. That's it. That means what? You just need to remember these two formula. This is the first one, and then this is the second one. Then what about tangent thing? You just divide these two expressions, and now you have turned everything into a polynomial of ei theta. And you don't care about this ei theta, you call it x. Then you have turned everything in sine cosine integration into some polynomial, and you know how to do polynomial. Good. And after you do so many steps, what you do? You turn it back to the original thing. Done. So here is the idea. So suppose I don't know this, okay, or I don't know this. So cosine, because of green box, give me this, and then you will see, oh my gosh, I have so many equal signs. No, they are just algebra. And again, I show you so many equal signs, it's just to let you understand the idea. The math, if you do it in yourself, you are not going to write so many equal signs. You will jump steps, and those steps are very easy to jump. Okay, so let me come here. So what is this? I put a 2 here, right? 2i is here, I is here. Okay, this is the first non-trivial thing, because now my stuff have some I thing. So I just see everything as I thing. Then that means what? I have to put this guy also I thing. So that's why the I go here. What is this equal sign? This is equal sign is just substitution. I don't want to see this ugly thing anymore. I just say this is u. Now I have this. And once you see this step, you know how to do. Okay, I want to solve this problem. So there are so many ways you can do. For example, now in this way, I divide something, multiply something. I get this, then I will get something like this. And this EU I can go inside because the EU is EU. Okay, then I this. Then again, I don't want to see so many complicated symbols. I change name again. I call EU as S. So I have this. Then what? Previously I showed you. Okay, maybe last page. This thing is this thing. Then done. I turn back from S. Then I have this EU, and then U is IX. So I have this. Now I have complex number. So actually at this step, you can already jump to conclusion if you know this complex formula very well. But here I do more explanation. So I make it half. Why I make it half? Because I want to make this guy appear. That's the idea. So I have do this. Then now I have this come here, become half, positive. This come here, become negative half. Okay. This come here and here are the same. And then I divide by 2 and divide by 2. I can do that, right? So now this thing, this one is cosine. On top, I need a I. I don't have I. Then I create an I. So I create I on top and the bottom. Then the top becomes sine. And I have a thing I in bottom. Does not matter. And then this one is what? Tangent. So I have tangent. And then I have 1 over I. So that means you need to know how to find the absolute value of 1 over I. Which is what? 1 over I. Okay? And then this gives you negative 1. And then I. So that basically is it. What's the magnitude of negative I? Okay? Which is 1. Because this is the algebra. But if you think about the geometry, it asks you how long is this vector? 1. That's it. So actually, that means what? All this step here, you don't need to write down. You just can jump direct from here to here. And that's what we want, right? Done. So that means, if you do this, if you don't know the complex number way, either you do some very tricky substitution, or you use very tricky trigonometric formula, or you use complex number. And for me, I always use complex number, because nobody will remember this. So the thing that makes integration hard, one of the reasons is that this kind of sine cosine thing is just very tedious. For example, this, oh my gosh. But okay, let's see what happens if I do this using complex number. Now I have, let's say, sine power 7, cosine 2m plus 1, 9. Let's say I want to do this. What's the classical way? Okay, do everything here. Nobody will do that, okay? So I turn everything to complex number. So it will be EIX minus E negative IX divided by 2I power 7. Cosine is EIX plus E negative IX divided by 2 power 9 dx. I do the same thing. EU minus E negative U and then 2I. Now I can separate them, right? And then here is EU plus E negative U 299 D. And then this is X. I haven't changed it to U, but later, okay? Then because I need the I. So now I decide I 7 times. Okay, I 7 times is, okay, you do the stuff, there will be an I, okay? Then you put an I here, then this becomes U. And then you simplify this two number, so it will be 216. So you take this out. We don't care. And then now you finish this. So I have now what? Ignore all constant. So basically you have something like what? S minus this is something like this, right? Then you keep going on. Done. This is what we can do. But if you don't do this, you want to solve this, okay. Very, very tedious. So complex number is the best. So this one, okay, this one you get arctangent, right? Okay, so classical way, you define x is tangent t. So because of this, then 1 is what? Secant, okay, because of this, then we have this, so dx dt give me this, and then you have this, all this thing, blah, 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 blah. Okay, let's see what happens if we do complex number. First step is not trivial. Right? It's the same, right? Then, right? Then, right? Then, right? Then you go back, okay? And then you simplify stuff. And then you got this. Something like that, yeah. So you can even don't need to care about trigonometric substitution. The idea is, okay, don't live in a one-dimensional world, become an angel, live in a two-dimensional world. Now you see a bigger world. You see a bigger world, you have more opportunity to move. Then after you do stuff here, project back to real life. This is what you should do. This is a very important technique. You suppose don't know this technique, but I just tell you now.